All right, let's try some practice problems for quiz 2. In question 1, we want to write the following Hindu Arabic numerals in Roman notation. And note that I is 1, V is 5, X is 10, and L is 50. So for this one here, well, first, if you want to get to 70, the fastest way to get there is 50 and then 2 more. So I can write this as L for 50, and then an X for 60, and another X for 70. To address 8, I can do 5 and then 3 more, so I'll put V, I. And this is 78. For 32, so I don't want to use 50, I can count by 10 until I get to 30. So I can say, all right, X is 30, and then to get 2, I can just do I for 1, 2. I think I'll include one more. What if it was 39? What about this? How could I write this as Roman numerals? So for 30, you can still use X, X, and X. But here 9 is 1 less than 10. Instead of doing 5 and then 4 more, it's shorter to say, let's do 1 less than 10. So I can write that as IX. Remember that sometimes you have to go backwards. It's not always simply additive. It sometimes is subtractive. For question 2, I want to use the divisibility tests to determine whether 3, 4, or 5 divide into 343,400. The rule for 3 is, if the sum of the digits is divisible by 3, then 3 divides this number itself. So what I'll do is, I'll take all the non-zero digits in 343,400, which is 3, 4, 3, and 4, and I add them together. That's 8 plus 6, that is 14. Now the question is, does 3 divide the sum of the digits? Does 3 divide 14? In fact, the answer is no, it does not. Because 3 does not divide the sum of the digits, 3 does not divide this number. So I'll say for this one, no, 3 does not divide this. The rule for 4 is, if 4 divides the last 2 digits of the number, then 4 divides the entire number as well. So here, what we're checking to see is it true that 4 divides, well, really 0, 0, but you would write that as 4 divides 0. Is that true? Yes. And therefore, 4 works. And the last one for 5, does 5 divide this number? 5 divides a number if the number ends in a 0 or a 5. I'll say the number ends, I'll say 343, 400, ends in 0. And therefore the answer. Question 3 is another divisibility test. Does 9 divide 19,296? So here, this is supposed to be a, does 9 divide into this integer? Now, what is the rule for divisibility by 9? If 9 divides the sum of the digits, then 9 divides the actual number itself. So I'll take the non-zero digits of 19,296, add them up, and see what we get. So 1 plus 9 plus 2 plus 9 plus 6. What does that equal? Well, this is 10, 12, 21, 27. Does 9 divide 27? And the answer to this is yes, it goes in 3 times. Therefore, this is true. I don't know how many times it goes in, but 9 certainly divides 19,296, and we used this rule to justify it. And finally, in question 4, I'd like to evaluate these expressions. That is, simplify them down to a single number. For A, what is the absolute value of negative 7? Well, that is equal to positive 7. And the reason for that is this is the distance negative 7 is from 0. Distance is positive. For part B, we have negative 4 minus a negative 3. So for this, we have negative 4 A minus is the same thing as adding 3. So I'll note here that a minus is the same thing as addition. Now we have minus 4 plus 3. I know the answer is negative. In fact, it's negative 1. For part C, here we're dividing 10 by negative 2. Just like with multiplication, if you're dividing two numbers and one of them is negative, the entire answer overall is negative. This is the same thing as negative 10 divided by 2. And 2 goes into 10 a total of 5 times. Parts D and E are very similar to each other. This is negative 2 to the 4th, and this is also negative 2 to the 4th, but this one has parentheses. For part D, if we follow order of operations, we will do an exponent before we do multiplying by a negative. So first, I want to compute 2 to the 4th, and then multiply it by negative 1. So off to the side, I'll note that 2 to the 4th means 2 times 2 times 2 times 2. And 2 times 2 is 4, and 2 times 2 is 4. This is really 4 times 4, and 4 times 4 is 16. So this is negative whatever 2 to the 4th is. 2 to the 4th is 16, so this is negative 16. If you compare that to part E, here negative 2 to the 4th means we're applying this 4 to the negative as well. In fact, this means take negative 2 and multiply it to itself a total of 4 times. So negative 2 times negative 2, a negative times a negative is a positive. So negative 2 times negative 2 is also positive 4. And this is positive 4 as well. So this is 4 times 4. 4 times 4 is 16, which is the answer to part E. So notice that D was negative 16, but E was positive 16.